All right, so SISAS module number 2, lesson number 4. In this lesson, we're going to talk about external authentication, how to integrate Cisco ISE with an external authentication source, maybe Active Directory. What are some of the different authentication methods that I can use with Active Directory? We'll talk about AD group memberships, some of the different methods that we have for integrating ISE with Active Directory. What is the actual integration procedure? How do we configure the AD domain and store? How do we test that connection to Active Directory? How do we join ISE to the Active Directory domain? How do we select different groups from Active Directory? How do we identify ISE, the identity source sequence? You know, if we're trying to identify Active Directory as an identity source, and then configuring that identity source sequence, applying the identity source sequence in the authentication policy, and then verifying external authentication, the final step in this discussion, right? We know that ISE is going to support a number of different types of external authentication sources, and these are basically our quote-unquote authentication servers that maintain databases and user attributes and whatnot. The external authentication sources are pretty common in most enterprises where authentication needs to take place, whether it's in a voice environment or a security environment like this, but it provides a single platform that allows us to pass, credentials and credentialed information between different components or different components in our architecture. So we don't have to build or maintain different databases for authentication throughout our enterprise. When it comes to external authentication, ISE can have a single authentication source, which is pretty common configuration, or we can actually reference a sequence of authentication sources that could include things like Active Directory, LDAP, Radius, RSA, and so on. A lot of companies will deploy kind of an authentication framework to use these external repositories for storing user accounts, user attributes, and so on, so that we have only one area that we need to gather information from, one authentication source where we're going to gather our authentication information from. That's essentially what this centralized database configuration is. It allows ISE to identify this external identity source, and then we can provide redundant identity sources as well for failover, and then we can authenticate our clients against these different identity sources, whether we identify a single source or we specify multiple sources in a sequence. Like I said, there are essentially 4 different sources that we can reference: Active Directory, LDAP, Radius, and Secure RSA. All right. Now, as far as Active Directory goes, this is not a Microsoft class by any means, but we do need to kind of understand what the structure of Active Directory is and how we can utilize that information to be able to integrate this information into our ISE environment. Obviously, we know that this is a directory service that Microsoft developed for specific Windows domains, and it's used for the Windows Server operating system. But as far as Active Directory service goes, or domain service, we're going to run this typically on a domain controller, and it's going to allow us to authenticate and authorize users and computers in that Windows domain based on the structure that we see here. It allows us to assign and enforce different security policies for all the computers that we're installing on our network, and then of course we can pass this information back to our ISE platform so that we can integrate the user and group authentication into the ISE platform as well, using some sort of, I wouldn't really necessarily call it a federation service, but kind of a relationship that ISE has with Active Directory. Active Directory uses LDAP, the Lightweight Directory Access Protocol. It can also work with different versions of Kerberos, and of course it's going to integrate with DNS as well. All right. Now, as far as the database goes itself, it does have a very logical structure. Active Directory instances consist of a database, and then we have executable code that's responsible for servicing requests and maintaining that database. There is a executable part of this, and I don't know that we need to really get into the details of this, but given that we're talking about Active Directory, I guess I might as well mention it. There's something called the DSA, which is the Directory System Agent. Usually just a bunch of Windows services or processes that are running that allow us to communicate with the Active Directory structure, right? Now, Active Directory has forests, it has trees, and it has domains. Basically, these are all objects that are arranged in a structure to form our Active Directory architecture. There's essentially two different categories that fall within Active Directory. You've got resources, like printers and so on, and then you have what we call security principals, which are users, computer accounts, groups, and so on. And then each of the security principals get assigned a unique security identifier, or what we call a SID, or SID. So each object represents basically a single entity. Could be, like I said, a user, a computer, a printer, a group, and so on. And then there are some attributes that are associated to those individual entities. And then we can also have nested objects, so some objects can contain other objects as well. Essentially, an object, all it is, for lack of a better term, is just some sort of unique entity that it's identified by its name and maybe a set of its attributes that might exist. Now, as far as what we see on the slide here, the forest and the trees and the domains, this comprises the actual framework of Active Directory. The framework that holds the objects is viewed in kind of different levels, if you will. The forest, the tree, and the domain are essentially logical divisions of this Active Directory network. Objects are grouped into domains. Maybe the objects for a single domain might be stored in a single database. That can be replicated. The domains are typically identified by their DNS name structure or namespace. And then that domain is defined as essentially a logical group of network objects. Computers, users, devices, and so on, and those will share they'll be shared in the same Active Directory database. A tree, in other words, in another sense, is really just a collection of one or more domains, and the domain trees are part of a contiguous namespace, and they're linked based on kind of a transitive trust hierarchy. Again, not really necessary that you guys know this for the test, but it is kind of beneficial to understand basically how Active Directory is constructed. At the very top of this structure, we have the forest. The forest is just a collection of trees that share common things like global catalog, directory schema, logical structure, directory configuration, and so on. The forest basically represents the security boundary, if you will, where users, computers, and groups are accessible within the group. All right. One of the most common elements that you're going to reference inside of a Active Directory structure are organizational units. These are objects held within a domain, and they're grouped into something called an OU, or an organizational unit. It provides a little bit of hierarchy to the domain, makes it a little bit easier to group things together or group elements together so that you can apply common security profiles to these different elements, like group policies, right? In fact, the OU is really the recommended level at where you apply these group policies, and those are called GPOs, right? Group Policy Objects. Although you can actually apply policies to the domain or the site as well, the OU is really the level where the administrators usually delegate specific elements, right? The OUs themselves don't actually have a separate namespace, like user accounts with an identical username in different OUs within a domain aren't actually allowed. You couldn't have, bob.cisco.com and bob.cisco.com, where you have maybe different domains, right? Not cisco.com, but maybe cisco.local versus cisco.com. The SAM account name, the user object attribute, they have to be unique within the domain. And again, it's not really important to understand because we're hoping that the Active Directory piece is already established. Our only goal in the case of ISE is to be able to integrate to that Active Directory domain. So the book kind of breaks it down a little bit into kind of a basic concept, right? An object is an object in Active Directory, like a user, a client, a PC, a printer, etc. The organizational unit is a logical grouping of objects within the domain, and they're organized based on their network design. They could be a collection of users in the same corporate group, servers in the same cluster, printers on the same floor, and so on. The domain itself is kind of like the top level. Well, not the top level. The forest would be the top level, but a host of objects that are logically grouped based on the organizational unit. And the tree is a collection of these domains. And then finally, the forest is the top level of the Active Directory, and so on. All right. One of the things that I want to mention is, and we see this quite often, especially if the backend server, the backend databases that we're communicating with are on different subnets or in different networks, is to understand a lot of the different port numbers and protocols that are used. Typically, obviously, NTP, if we're doing some sort of time synchronization, UDP port 123, the global catalog, TCP 3268 and 3269, SMB, TCP 445, LDAP 636, and LDAP 389 for UDP and 389 for TCP. So these are different components that are required. You can see on the slide here it says Active Directory is a widely deployed directory structure, hierarchical format that allows logical groupings of users and devices, requires accurate time, 5-minute difference between ISE and AD, so that's a little asterisk that you want to make note of. So we certainly want to make sure that the ISE platform and our Active Directory architecture are synchronized. Doesn't necessarily mean that they have to be in the same time zone, but they have to have the same time stamp, essentially, based on based on that 5-minute difference. Anything above 5 minutes will cause some serious issues. And then, of course, make sure that we have those specific ports open. You might not need all those ports, but some of those ports might need to be open. All right. The ISE platform supports lots of different authentication protocols. We've already gone through kind of the differences between a lot of these different protocols, but I'll just read a couple of these bullet points to make sure you guys understand. Eat fast with PEEP. ISE supports user and machine authentication and password changes against Active Directory using EAP-FAST and PEEP. Remember, that's an outer tunnel method with an inner tunnel method of MS-CHAP and EAP-GTC. The inner tunnel method is what's going to allow us to do the EAP chaining so that we can do user authentication and machine authentication simultaneously. It supports PAP, Password Authentication Protocol, meaning that we can authenticate against Active Directory using PAP. Basic username and password scenario, MS-CHAP v1, MS-CHAP v2, EAP-GTC, EAP-TLS, certificate retrieval based on TLS. Remember, in EAP-TLS, we have to do mutual authentication, right? Certificate retrieval based on the client, the endpoint, or the user machine that's authenticating, as well as the server that's authenticating. PEEP-TLS, using PEEP-TLS to communicate with Active Directory is supported as well. And then finally, LEAP. We can use LEAP to connect to Active Directory as well. All right. We can also improve the manageability of an authentication system by assigning users to groups. Group membership typically is going to be leveraged for assigning the same privileges to specific users. So obviously we can create a group and we can apply different settings to that group, and then based on the user's membership in that group, they'll essentially inherit those particular privileges for that particular group. If the user resides in an external repository, the group membership information has to be kept in the external repository. We can't kind of mix and match internal identification elements with external identification elements. So it's either everything comes from externally or everything comes from internally. We can't kind of mix and match the scenarios. All right. So ISE will allow you to set up Active Directory as a policy element. If you have Active Directory integration and that's configured, we can actually import the groups from AD into our directory. And then based on that, the attributes can be referenced based on the conditions and the requirements for our context-sensitive policies that are assigned in ISE based on what we're trying to accomplish from our authentication processes in ISE. Okay? LDAP, Lightweight Directory Access Protocol, also a standards-based protocol for allowing us to query, modify directory services that run over TCP/IP. It is a lightweight mechanism for accessing what we call our X.500 base directory services, and ISE integrates with LDAP by using the LDAP protocol, which is actually probably a little bit easier than doing some sort of full-on Active Directory integration using LDAP to synchronize a database. Essentially, the way that LDAP works, and again, we don't really need to get into the specifics of the protocol because that's not really the purpose of this course, but the way that LDAP works is it's a directory store, right? Vendor neutral, kind of a standard application protocol that allows us to provide directory services over an IP network, all right? It was actually specified as a standard by IETF. And there were a couple of different RFCs. There have been a few different versions. I don't remember what the RFC numbers are, but it's basically part of the X.500 standard. And because of that relationship, it's often called like X500 Lite or and so on. But as a protocol itself, there is a directory system agent, uses TCP and UDP port 389, or if you're running as LDAP over SSL, that's going to use port 636, excuse me. And we send essentially client requests, and then the server sends responses with a return. All right. And in the case of LDAP, there's multiple messages that might go back and forth. We might, say do a search or, abandoned or start TLS and so on. But the directory structure is based on the X.500 model, which was developed in the early 90s, I believe, which just is basically a collection of different attributes, right? A distinguished name as an example, a relative distinguished name, and so on. All right. Now we can authenticate. Typically in the authentication process, we call that a bind. We can add elements to the LDAP directory and so on. So basically LDAP is just a directory that's organized into a tree structure, much like Active Directory. It has a hierarchy. And then it can be distributed, this whole structure or this database can be distributed across different servers. Each server has a replicated version of that directory, and then that gets synchronized periodically. An entry in the tree contains specific attributes that are necessary to tie to that particular user. All right? And the attributes are actually defined in something called the schema. ISE has actually 3 predefined LDAP schemas. We have Active Directory, Sun Directory Server, and Novell Directory, although Active Directory is probably the most common one. We can access the Active Directory database either directly as Active Directory or as an LDAP server. Different methods have different reasons for using them. There are pros and cons, obviously, to both. If we connect to the AD repository using the Active Directory method, we get a direct tie between ISE and AD. lots of attributes. We can search up and down the tree and so on. If we connect to AD as an LDAP server, we get the option of joining multiple directories, but it's, from a performance perspective, is a lot slower. Although I will say, and Andy, this goes to what you were saying earlier, a direct LDAP integration is actually a little bit more seamless, a little bit easier to manage than an Active Directory integration. And typically that's what we've done in the past. If we've decided to do any kind of external repository, we've decided to use LDAP as our integration instead of Active Directory. So we're going to take a look real quick in this lesson about how do we integrate Active Directory into our ISE platform. We basically go through 4 different steps. Number 1, configure Active Directory domain name and the store in ISE. Number 2, we test that server connection. And then number 3, we join the ISE nodes to the directory. And finally, we select from the groups, we select the groups that we want to import or be able to modify, or to be able to reference from Active Directory in the structure. So let's take a look at what that looks like in the configuration itself. Go to Administration, go to Identity Management, External Identity Sources. From the External Identity Sources navigation pane, we're going to click Active Directory, and then you'll see the AD page appear on the right side of the right pane. We put in the Active Directory domain name in the domain name text box, and then we specify the identity store. In this particular case, the identity store was AD1. That's actually the default value, so you're probably going to want to modify that based on your Active Directory structure. We save that configuration. All right. The next thing that we will do is we will go in and we will test that AD configuration. We can do a basic test or we can do a detailed test. The basic test is just going to test for essentially just basic authentication, whereas a detailed test is going to report specific details about that Active Directory server, right? The IP address, the fully qualified domain name, the host name, and so on. And there's a whole list of other things that will show up in that connection test. All right. We still haven't specified the authentication credentials, but that will be next. We're going to go in and specify or join the Active Directory domain. We've submitted the configuration already. We have to click Join to actually connect the ISE server to the Active Directory domain. You do have to manually perform a join operation for each PSN that you want to be connected to the AD. Even though these PSNs tend to operate in a clustered environment, every PSN has to be joined to the domain manually. All right. So we go to Administration, System, Active Directory Operations, choose the node that we want to be joined, to Active Directory, and then click the Join button. All right. This is definitely something that you guys will be doing in your lab exercise a little bit later on. Once I've authenticated to the Active Directory server, I can select groups from the directory, and then it can, it'll pull a list of all the groups that we will that'll be listed. You'll see that the limit is 100, although I don't typically see more than 100 groups in an Active Directory architecture, but we can only pull 100. So we may have to specify a filter if we do have more than 100 groups in the Active Directory domain. And then I can simply apply a checkbox to whatever groups that I want to reference when I'm doing my authentication in ISE, right? And then I can retrieve that group information by applying a filter or by simply putting an asterisk, which is going to retrieve any possible group from the list. All right. Then we simply check the groups that we want to retrieve, uncheck the ones that we're not going to use in our authentication and authorization functions on ISE. All the groups will actually be unchecked by default, so then we'll have to go in and specify which groups we want to get information from. All right. We can choose, if we'd like, to identify multiple identity sources in a list. This is called an identity source sequence in the case of ISE. So an identity source sequence is essentially a defined order where ISE is going to look for user credentials in different databases in a consecutive order. If the user information is in more than one database, we can define the order that we want to use to authenticate those individual users. Remember, we do have the ability with ISE to use different types of identity sources. The identity sources themselves contain user information that ISE is going to use to validate credentials during the user authentication process. And we use these different identity sources to retrieve group information and other attributes that are essentially associated with the user for use in our authorization policies as well. Essentially, they're just databases, right, that store information, store users' information in the form of records, and then we want to reference those records and so on. So Cisco ISE does support an internal identity source, which Andy was talking about previously, or you can use an external identity source, which is what we've been talking about in this particular lesson, right? You can actually configure an external identity source that contains user information. We're going to then connect to that external identity source to obtain the user information for the purposes of authentication. The external identity sources could include things like certificate information, so that the ISE server can use, or certificate authentication profiles, and so on. If it's internal, all right, so let's say, for example, we have four options, right? We can do internal, we can do Active Directory, we can do LDAP, or we can do Radius Token Servers, or RSA. One of the things that you need to keep in mind, though, is that not every protocol, not every authentication protocol is available for each identity source. They don't mention that in this particular slide, but it is something to consider. For example, EAP-GTC, PAP, that's going to be available for all four. But if you're going to run something like MS-CHAP or MS-CHAP v1 or MS-CHAP v2, that's going to be supported internally and with Active Directory, but it's not going to be supported with LDAP or Radius or a token server. EAP-MD5, CHAP, that's going to be supported only with the internal database and not with the other three options. And then with EAP-TLS and PEAP-TLS, we're going to be able to support authentication and certificate retrieval. For EAP-TLS, we're talking about certificate retrieval, not user authentication, with our internal database, with Active Directory, with LDAP, and so on. So it's important to note that whatever method you decide to use corresponds or can be correlated with the authentication protocols that you want to use. Make sure that the authentication protocol that you're identifying is supported by that external identity source. Very important concept. All right. And so that's what we're looking at on this particular slide here, is just a reference to multiple identity sources. And once a match is found, ISE is going to stop looking. So it's going to go through this list and it's going to evaluate the users against the database. Once it finds a match, it's going to apply that to the policy based on a first match. The ISE behavior is configurable for different situations. So what do I do if a database cannot be accessed? Do I move on to the next database? Do I put the user into a restricted domain or restricted VLAN, and so on? In this particular example, we're seeing an identity source sequence of 3 different databases: Active Directory, LDAP, and then internal database. The user is actually not found in the AD database. So then what happens is ISE then proceeds to search through the second data source, but the LDAP server is not responding. So that means that we're going to proceed to the next store in the sequence, which has been configured as the local ISE fallback, right? And then, of course, we see the authentication failed because the user was not installed in the local database. All right. So in this particular case, the authentication fails completely. Okay. How do I build this list? I go into identity source sequence under identity management, administration, identity management, identity source sequence, and then I can give it a name that kind of references what the sequence might include. In this case, 80 underscore internal, meaning that we're going to go to an Active Directory domain first, and then we're going to go to internal users second. And then I can specify the action that's going to be performed if a selected identity source store cannot be accessed for authentication. I have two choices here. I can say do not access other stores in the sequence, which is the default method, by the way. This will cause ISE to stop processing through the list. Or I can check the box as treat as if the user wasn't found and then proceed to the next store in the sequence. This is going to enable failover to the next store in the database if the first one is not available. All right. So what you're seeing in this example here is just a basic way to configure an identity source sequence that consists of 4 potential sources. Only 2 of them were selected, but we had 4 choices, right? Active Directory, LDAP repository, internal user database, and an internal endpoint database. Even though guest users is listed here, it's intended to be our LDAP integration, even though it's not listed correctly. Okay. Of course, once I've created the identity source sequence, my next step is then to apply that identity source sequence, and then we apply them to the authentication policy rules based on a result along with whatever protocol specification we apply as well. The configurable options for the failover scenarios: if authentication fails, if a user is not found, if a process fails, describes that behavior that we're going to see. We'll see this on the next slide, but this is something that we've already seen as part of our discussion previously, right? We have to identify if authentication fails, what do we do? If the user is not found, what do I do? And if the process fails, what do I do? All right, and that's what we see on this particular slide right here. A way for us to identify what we're going to do based on those scenarios. Okay. The final step would be then to, this is where we're referencing, by the way, our identity source in our rule. This is our .1x rule that we're creating, wired or wireless 802.1x, default network access, and we're specifying the AD, sorry, let me clean that off. We're specifying the AD internal identity source sequence that we configured previously. Okay, so if authentication fails, we're going to reject. If the user isn't found, we're going to reject. And we're actually going to send a message back to the network access device saying access reject, so that the client will actually be identified that it's being rejected. And then finally, if the process fails, we're simply going to drop, meaning that the process fails means that the sources are not available, we can't reach them, so we're not going to send specifically a reject back, we're simply going to drop the request. Okay. ISE provides a summary of all the different authentications that take place. We can go to Operations in Authentications menu, click on the Details button. We can see what identity source has been actually used to authenticate the client. In this case, Sales 1. This is, by the way, part of the lab that you would have to do on the exam, is to identify the identity source. I believe that's one of the questions on one of the hotspot questions on the lab. But and that's pretty self-explanatory, right? We see the client, the time that the client was authenticated, the status of a check mark indicates that the client was authenticated. We can see the details. The username was Sales1. Policy server was ISE. We only have one policy server in this particular case. The IP address is 10.10.9.11, and the identity store was 81 in this particular case. So we went through, we were able to find this user in 81 and authenticate them based on that. Okay. So that concludes this lesson. We talked very quickly about some of the options that we have for authenticating users against either a local database or an external database. Talked a little bit about the Active Directory structure and and how we can identify components within Active Directory, integrate Active Directory as an authentication option for ISE as an individual identity source, or we also identified how we could create an identity source sequence to create a chain of authentication options, primary, secondary, tertiary, and so on. And then we finally looked at how we can reference that identity source from our authentication policy rules. All right, so that actually concludes module number 2. We're going to get into module number 3 next, which is where we basically talk about advanced access control. This is where we talk about stuff. Andy, you may not be using a lot of this stuff, so this might be something new to you as well. Security group access, MACsec, how we implement client authentication with ETLS and certificate-based authentication. And then we're going to go into the authorization piece. We've already gone through the authentication piece. Then we're going to get into the authorization piece, and then finally talk about SGA, MACsec, and so on. So we'll see you guys in the next lesson.